Let's solve some systems of equations. I have the equation 2x minus 6y equals 10 and negative 3x plus 9y equals negative 15. I'm going to solve this by elimination, and I have decided to eliminate the x's. I have 2 and negative 3. I'm going to make these a 6 and a negative 6. In order to do this, I'm going to multiply the top equation by 3, because 3 times 2x would give me 6x. I'm going to multiply the second equation by 2. And 2 times negative 3x would give me a negative 6x. Therefore, they will be eliminated. Let's go. The first equation, multiplying everything times 3. 3 times 2x is 6x. 3 times negative 6y, negative 18y. And 3 times 10 is 30. The second equation, I'm going to multiply by 2. 2 times negative 3x is a negative 6x. 2 times 9y is 18y. And 2 times negative 15 is negative 30. Let's add them up. 6x and negative 6x, they cancel. They are eliminated. I planned it that way. Negative 18y and a positive 18y also cancel. I have 0 on the left side. On the right side, 30 and a negative 30 is 0. I lost my variable. There is no x or y, but 0 equals 0 is a true statement. These must be the same line. They have infinite solutions. The way I could write this, every x and y is an answer as long as it's on this line. And I could write either line. I'll just write the first one. So I do have infinite solutions, but they have to be on that line. So once again, this notation down here, it's every point, which means every x and y that is on that line. Let's see how this looks when we graph it. How would I put this into my calculator? Well, I would have to solve for y. So very quickly, the first equation, I'm going to solve for y. So I will subtract 2x from both sides. I will now divide everything by negative 6. I will have y is equal to negative 2 divided by negative 6. That's a positive 1/3. And 10 over a negative 6, that will be a negative 5/3. Now let's move this out of the way. And I'm going to take the second equation and solve for y. When I divide 3 by 9, I will get 1/3 x minus, and that'd be 15 divided by 9. Maybe you already see this. 15 divided by 9, that is 5/3. These are going to be the same equation. Let's quickly graph this and see what happens. So I solved the first equation for y, I solved the second equation for y, and I didn't reduce it all the way. And these are what I'm going to plug into my graphing calculator. I have already typed the first equation in, 1/3 x minus 5/3. I will type in the second equation. I am putting 1/3 in parentheses, that is 1/3 times x minus, and I'll put 15/9. I will graph it, and there is my first line. And there is my second line. It is the same line. So once again, these are my two equations after I solved for y, and I reduced it this time. Did you notice they had the same slope, which means they're either parallel lines or the same line, but they also had the same y-intercept. Therefore, they are the same line. Let's try one more. Solve this system of equation. I'm going to eliminate the x's, but remember, we can eliminate the x's or the y's. So I will multiply the top equation by a negative 3, and the second equation is already 3. Negative 3 times the first equation, I will have negative 3x minus 12y. And negative 3 times 8, don't forget to do that right side also, will be negative 24. The second equation, I am going to rewrite that. I like to keep my system of equations neat. Keep that equal mark lined up so you won't get confused. Let's add them up. Negative 3x and a positive 3x, they are gone. They are eliminated. I planned it that way. Negative 12y and a positive 12y are also eliminated. I have 0 on the left side. On the right side, I have negative 24 and a positive 2. That would be a negative 22. I have lost not only my x, I have also eliminated my y's. I do not have a variable, and 0 does not equal negative 22. This is false. The answer here is no solution. These two lines have nothing in common. Let's graph this. In order to graph this with my calculator, I will need to solve both of these equations for y. The first equation, divide everything by 4. And now the second equation, divide everything by 12. Let's look at these equations. The slope of both lines is negative 1/4. Once again, that means that these must be parallel lines, which means they would have nothing in common, no solution. Or either they're the same line. How do I know that they are not the same line? Well, they have different y-intercepts. One will cross the y-axis at 2. The other one will cross the y-axis at 1/6. Let's type this into our calculator. Okay, I've typed in my first equation. Make sure when you type in this negative that you do use the button underneath the 3. I also make sure I put my fraction in parentheses. Let's graph. We have our first line, and look, it does have a negative slope. You see that line going down, 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 down? And the second line, yes, sure enough, this is no solution. They do not have a point in common. The first line does cross the y-axis at 2, and the second line, you can't really tell, but it does cross at 1/6. They both have a negative slope. I love to be able to demonstrate the algebra connected with the graph. Have fun!